The alien next door. If you want to see something that feels like it belongs on another planet, you don't need to leave Earth. You just need to look under the waves. Octopuses are master escape artists, problem solvers, shapeshifters, and stealth hunters, all wrapped into one soft-bodied animal with no bones, 3 hearts, and a brain system spread throughout its arms. They can squeeze through openings barely larger than their eyes, taste the world with their skin, and vanish in plain sight in a blink. But here's what makes them even more amazing. Every part of an octopus is built for a life of constant adaptation, finding food, avoiding predators, and surviving in an ocean that can change minute by minute. In this video, we're going deep into the octopus's world, where it lives, how it hunts, how its organs work, what its intelligence looks like, and the rare, astonishing facts that make it one of the most extraordinary creatures on Earth. What is an octopus? The body plan. An octopus is a cephalopod, part of a group that includes squid, cuttlefish, and the chambered nautilus. Cephalopod means head, foot, and that's not an exaggeration. An octopus is basically a muscular head with arms attached, evolved into a perfect underwater machine. Most octopus species are solitary. They're not schooling animals like fish. Instead, they tend to live alone, defending a small territory and choosing hiding spots that offer protection and good hunting access. Their soft body lets them hide in places a rigid animal never could. Crevices, coral rubble, rocky holes, shipwreck cracks, even discarded bottles and cans. Octopuses vary a lot by species. Some are small enough to fit in your palm. Others, like the giant Pacific octopus, can span several meters arm to arm. But across species, the same design shows up again and again. A central body, the mantle, 8 arms with suckers, a strong beak, and a set of internal organs built for fast, efficient movement and stealth hunting. Where octopuses live, dens, depths, and neighborhoods. Octopuses live in nearly every ocean on Earth, from warm tropical reefs to cold temperate coasts and even deep-sea environments. Many species prefer the sea floor, where they can hide, crawl, and ambush prey. You'll find them around coral reefs, rocky shorelines, kelp forests, sandy bottoms, and deep-sea slopes. A key part of octopus life is the den. Think of it as a home base, part shelter, part pantry, part fortress. An octopus will often choose a hole or crevice and then decorate it. You might see shells, rocks, and bits of debris placed around the entrance. This isn't random. It can act like camouflage, a barricade, or even an early warning system. If something disturbs the pile, the octopus knows. Some octopuses also create middens, basically trash piles of shells and crab parts outside the den, evidence of repeated meals. To predators, it can be a dangerous clue. To scientists, it's a sign that a den is active and a window into what the octopus has been eating. Movement, jet power, crawling, and the boneless advantage. Octopuses move in 3 main ways: crawling, swimming, and jet propulsion. Crawling is the stealth mode. They use their arms like flexible legs, flowing over rocks and coral with surprising grace. This is quiet and controlled, perfect for sneaking up on prey or staying hidden. For faster travel, they swim by undulating their arms and body. But when an octopus needs an instant escape, it uses jet propulsion. The mantle draws water in, then blasts it out through a muscular funnel called the siphon. That jet of water launches the octopus backward like a biological rocket. It can even steer by aiming the siphon in different directions. And then there's the soft body advantage. No rigid skeleton. That means an octopus can compress its body dramatically. If the beak can fit, the octopus can usually fit, because the beak is the hardest, largest fixed structure in the body. This is why they can escape tanks, squeeze through tiny cracks, and hide in impossibly small spaces. The inner organs: 3 hearts, blue blood, and a mantle engine. Now let's open the hood, because octopus anatomy is wild. 3 hearts. Octopuses have 3 hearts. 2 branchial hearts pump blood to the gills, where it picks up oxygen. 1 systemic heart pumps oxygenated blood to the rest of the body. Here's the twist. When an octopus swims using jet propulsion, the systemic heart can slow down. That's one reason many octopuses prefer crawling. Swimming is exhausting. Blue blood. Octopus blood is blue, not red, because it uses hemocyanin instead of hemoglobin. Hemocyanin is copper-based, and it's especially useful in cold, low-oxygen environments. The trade-off is that it's less efficient than hemoglobin at carrying oxygen in warm conditions. So many octopuses rely on efficient gills and careful energy use. The mantle. The mantle isn't just a body sac, it's a muscular engine room. It houses key organs and powers jet propulsion by moving water in and out. Inside are organs for digestion, circulation, and reproduction, all packed into a flexible, efficient system. The arms, a distributed brain and taste on the skin. An octopus arm is not just an arm, it's a semi-independent decision-making machine. Octopuses have a large central brain, but they also have a huge number of neurons in their arms. Each arm can process information and perform complex movements without the brain micromanaging every action. This is how an octopus can do multiple tasks at once. One arm can explore a crevice, another can hold position, another can manipulate an object while the body stays hidden. Suckers. Grip plus sensing. Suckers aren't just suction cups, they're packed with sensors. Octopuses can taste and smell chemicals through their suckers, meaning they literally sense the world by touch. Imagine touching a rock and instantly knowing if a crab just walked over it. That's the level of information their arms can pick up. Octopus arms also have incredible strength and dexterity. They can pry open shells, move rocks, and manipulate objects in ways that look startlingly intelligent. Hunting. Beaks, venom, and the perfect ambush. Octopuses are predators. Many hunt at night, using stealth and surprise. Their diet often includes crabs, shrimp, clams, mussels, and small fish. The beak. At the center of the arms is a sharp beak, similar in concept to a parrot's beak, used to bite and break into prey. Under the beak is a tongue-like structure called the radula, used to rasp and help pull food in. Venom. Many octopuses have venom delivered through their bite. For most species, it helps subdue prey like crabs and can begin breaking down tissues. One species, the blue-ringed octopus, has venom dangerous to humans, another reminder that these are serious hunters in small packages. Shell drilling and strategy. Some octopuses drill into shells using a combination of scraping and chemicals, creating an opening to inject venom or pull the animal out. Others use brute force, prying shells open with their arms. They adjust strategy depending on the prey type, like a hunter choosing the right tool. Camouflage, color, texture, and disappearing in plain sight. This is where octopuses turn into living special effects. Octopus skin contains specialized cells. Chromatophores expand and contract to show pigments, browns, reds, yellows. Iridophores reflect light, creating shimmering effects. Leucophores scatter light to match brightness and background tone. But color is only half the story. Octopuses can also change texture using muscle-controlled bumps called papillae. They can go from smooth to spiky, from flat to rock-like in seconds. Combined with posture and movement control, an octopus can blend into coral, sand, rocks, seaweed, almost anything. They use camouflage for hunting, hiding, and communication. A flash of color can signal alarm or aggression. Patterns can warn arrival. It's like having a screen built into your skin. Intelligence. Escape artists, tool users, and problem solvers. Octopuses are among the most intelligent invertebrates known. They can learn through observation, solve puzzles, and remember solutions. In controlled settings, octopuses have been documented opening jars, navigating mazes, and working out how to reach food rewards. Escape skills. Their combination of strength, flexibility, and curiosity makes them famous escape artists. They can push lids, fit through small gaps, and explore their environment with determination that looks almost human. Tool use. Some octopus species have been observed carrying coconut shells or using them as portable shelter, one of the clearest examples of tool use in an invertebrate. Others use rocks and shells to barricade dens. Even more amazing, they seem to have individual personalities. Some are shy, some are bold, some are aggressive, and some are surprisingly playful. Life cycle. Short lives, intense parenting, and a final act. Many octopus species live relatively short lives, often 1 to a few years. Their life strategy is fast growth, intelligence-driven survival, and a powerful final reproductive cycle. After mating, many female octopuses lay thousands of eggs and guard them intensely. During this time, she may stop hunting and devote her energy to protecting, cleaning, and aerating the eggs. When the eggs hatch, the female octopus has done her job and dies soon after. It's a dramatic, heartbreaking, and biologically intense example of a life built around one final mission: the next generation. The tiny hatchlings enter a dangerous ocean world immediately, where only a small fraction survive to adulthood. And the cycle continues: stealth, adaptation, intelligence, and survival. Why octopuses fascinate us? Octopuses challenge what we think intelligence looks like. They don't live like we do, they don't think like we do, and their bodies are built in ways that seem completely alien. Yet they solve problems, adapt to change, and survive using a mix of instinct and intelligence that's hard to ignore. So, the next time you see an octopus, remember, you're looking at one of the most advanced and mysterious minds in the ocean, wrapped in a body that can vanish, escape, and outsmart in ways that still amaze scientists today.